So, hello everyone. First of all, and welcome to the session. Today we are having Tarun Mahwa sir with us again, and he'll be continuing the series of with Azure, and he'll be talking about implementing Azure Kubernetes services. And let me introduce Tarun sir. Like he's lead DevOps at ABB, and he's multi-phase personality, having an incredible experience with Azure. So, over to you, sir.
Yeah, good evening, Lakshit, and thanks for hosting me today evening. I know it's a weekend evening, but yeah, let's start to learn something. So the topic and agenda of today talk would be what is Kubernetes service and how to implement that same in the Azure. Yeah, I think Kubernetes came, I think, in 2014. It's been quite some time now, more than 7 years. I'm today I'm going to talk about and Google has it was a project in Google, and they publicly general availability. It was there in, I think, July 2014. It was there, like they have gone in the public preview. So today I'm going to talk about the Kubernetes version of Azure actually. And to begin with, I think I will be also sharing a couple of resources so that you guys can go through it. Probably the one of the site could be the Kubernetes.io itself, where you will find ample amount of information. And then the second reference which I'm taking is from the Microsoft official documentation site, that again comes under AZ400, under create and manage containers using Dockers and Kubernetes. So, so containers can be managed using both Dockers and Kubernetes. So I'm going to talk about the Dockers part of it. So let me share my screen. Yeah, so I'm just sharing my screen, and also will go through try to go through some demo and see how it functions. Yeah, so this is implementing Kubernetes services. So now the agenda is we'll go towards the introduction. I don't know those have those fancy slides, but I think it's good to walk through the official documentation of Azure, how they are implementing the Kubernetes. And how what is Kubernetes? So this is the agenda: introduction to Kubernetes, and then exploring Kubernetes services, what are different services we have, and then the architectural components. I will be describing some of the architectural components which are essential for today's to understand Kubernetes, as well as the demo part of it. And then we have understanding Kubernetes networking. We have then the Ingress controllers. Then we have the deployment units, and then we'll go to the demo and implementing. We'll see implementing it through the continuous deployment pipelines, and then we will also update the container images in the ACR. So that's a complete walkthrough how we'll go through. So first of all, like what's Kubernetes actually? So this is the one of the Microsoft documentation site. I will keep on posting some of the links, so you can help Lakshya to just post it. So this is like to start with. I think Azure is a very good platform to start Kubernetes. So Kubernetes, if you want to learn, you can go with either Google or Azure, because they are the early adapters of Kubernetes in terms of containers in Kubernetes. So these are the two. If you want to learn Kubernetes, you can go for either of these two clouds. So that's why also today I'm focusing on towards the Azure part of it. So introduction to Kubernetes. Kubernetes is a cluster orchestration technology that originated with the Google, as I said, and is also called as Kubernetes because there are 8 letters between K and S. And it is a platform for automating deployment, scaling operations, and containers. and it creates a container specific infrastructure. So it's not like we have only Kubernetes in market. We have other players like also, like I have taken from the this slide, so I'm just rolling back in here and there. So now alternative Kubernetes are the Mesosphere DCOS and Docker Swarm. Docker Swarm to run your container based application. So and then we will go towards the exploring the Kubernetes. So which is our the second part, exploring towards the Kubernetes services. So AKS is a Microsoft implementation, as I said, and it reduces the complexity and operation overhead Kubernetes by offloading much of response to Azure. Mostly is managed by Azure. I will show you the architecture components once we walk through after this slide. AKS manages much of the Kubernetes resource for the end users. They do by using they do it by making it quicker and easier to deploy and manage container applications. Then we it also eliminates the ongoing operational maintenance burden by provisioning and upgrading and scaling. Provisioning, upgrading, and scaling is all done by most of the part is done by Azure. So, but there are some customer managed also where we actually deploy the application. Some components are managed by Azure, and some are managed by the customer or the application to which they want to deploy the application. So that is completely managed by customer or you or me like. But some of that the part is managed by Azure. So that I will show you which architectural part belong to Azure and which part architecture belong to the application owner, application team, you can say. So Azure AKS manages the following aspect of Kubernetes cluster for you. It manages critical tasks such as health monitoring, maintenance, the simple cluster scaling. It enables master node to fully enable Microsoft. It leaves you responsibility only for managing and maintaining the agent nodes. It ensures master nodes are free and you only pay for the agent running nodes. If you are manually deploying Kubernetes, you will also pay for sources for the master node. So you will also pay for the master node. So now this is we will go to the architecture components. So see, this is when we go through the architecture components. So this is few of the architecture components which we then once we move through this one, right? Then I will different IKS components which will be going to deploy. I will just going to cover in this section only. So and then we will move to Kubernetes networking. It's not detailing because even I am learning Kubernetes networking. So, but whatever I know, I will tell. So yeah. But yeah, so to get started examining the AKS architecture components, the Kubernetes cluster is divided into two components. As I said, cluster master node, which provides the Kubernetes, which is the I think if you go, let me just have a read slide of it. So cluster master nodes, which is the left side of Kubernetes, which provides the core Kubernetes services and orchestration for application workloads. Nodes that run your application workload. So a Kubernetes cluster is divided into two components. One is Azure managed, one is customer managed. So the one you see in the left side of the square a rectangle is basically Azure managed, which includes the API server, etcd or scheduler, controller manager, and the right side is customer managed, which is composed of nodes. Nodes in turn are consist of the customer managed is is a cluster. A cluster is there, and then inside that a node is there, and inside a node there are n number of pods, and inside the pod there are container images which are running, which are actually the application hosted on top of the OS. So now our workload is being reduced. Our entire system is coupled in a container image that consists of your OS, your applications, your binaries. All it is contained in a containers. So see how we have evolved from a monolithic application to microservices application. That is also I will show you how we have moved towards this. But let's walk through the main heart of the Kubernetes, which is the these this architecture, which is you can say so left side is the Azure managed by Azure, which is the API server, etcd scheduler, controller manager. But when you configuring it is not like Kubernetes always for cloud. No, you can configure Kubernetes on the on-premise as well. But when you configure for on-premise, even the left side you have to manage yourself itself, like the scheduler, the controller manager, API server, and etcd. So these are services. These are core services, and the right side is the where your application is being deployed. and the actual application is being deployed in the node pools. So runtime and the container runtime in the container actually, where the and what you see in the square is if you see in the square, this is called as a container image, which is running inside a pod. So a Kubernetes cluster is divided into two components: cluster master node, which provides the core Kubernetes services, right, and orchestration of application workloads. This is the orchestration of application workloads. As Kubernetes is the orchestrating engine, so it orchestrates your code to be deployed in a compressed container format, and high availability also it offers. So today, very Kubernetes play is a it is a leader of deploying your microservice based applications. And nodes, the third comes the nodes that run your application work. So the node is where your application runs actually, which is customer managed. So the same thing is being shown here as well. Like Customer master and customer, you can these are the I think the main link I have given you. But yeah, this is also the like documentation which you can refer while you are also just going through the same thing, but uh, just you can just refer to it. So cluster master is over the left road. So when you create a AKS cluster, cluster master is automatically created, right? And the cluster master is provided as managed Azure resource abstract from the user. So etcd controller manager API server, it's all created already. And whatever you see in the so see, whenever we will see the demo, we will see how much we can cover. But I will at least provision AKS for you. I'm not confident of deploying the application also, but because that was failing for me when I tried today before the demo. So, but yes, at least I will make sure that you understand the concepts. So yeah, so the nodes, if you see, plus when you create a cluster is cluster master is automatically created. This is called so when we will walk through demo, you will see two resource group are created. One is the actual resource group where you want to deploy Kubernetes, and one is starting with MC underscore something. So that MC underscore something is where your application is being deployed, and the one which is you entitled for creating a Kubernetes cluster, that is deployed in the Azure managed resource group, which is the actual resource group. And the node one is where all the components inside the node, like of the container images, ACRs, and all those things, it will be stored in the separate cluster. So there will be two resource group created. One is MC and one is the actual resource group. So you will see the changes there. So customer manage would be the one which you mentioned, create a resource group, and the Azure manage will be starting with the MC, which is will be having the core components like node pools, scheduler, etcd API server, controller manager. All things with node pools, nodes will be there in the this all management will be there in the MC underscore resource group. And then the customer manage will be the actual resource group where you want to deploy your Kubernetes cluster. So yeah, that's the difference. So now when you see cluster master, the cluster master is containing of the couple of components which are which form the heart of Kubernetes. One is the API server. Like API server is how the underlying Kubernetes API is exposed. This component provides interaction of management tools such like kubectl commands. You will see the kubectl commands in the Azure CLI and Kubernetes dashboard that is maintained by Kube API server. API server is like to interact with your nodes. Once your nodes is deployed, you will use kubectl. So those kubectl commands are the API servers which interact with your nodes, which is towards the right hand side, customer managed. So this is the function of Kube API server. The other important component is the etcd. etcd is to maintain the state of a Kubernetes cluster and configuration, the high availability. etcd is a key value store within Kubernetes. It is a very important component in Kubernetes, and it should be always backup. It is a key value pair. It stores the key value pair, etcd. This is the thing. And then comes the Kubernetes scheduler. The scheduler determines what nodes can run the workloads and start when you create or scale applications. So scheduler is responsible for scaling. You can say scaling if any if any node needs auto scaling, if the Kubernetes application is auto scaling, if there's a peak during the highly transaction environment. It's a peak like period during the holiday season. So it's a scheduler schedules the Kubernetes jobs in a automatic fashion. So whenever the workload increases to in the right side to on the nodes, so it will automatically allocate nodes in a it will automatically allocate the pods and to the nodes. So it also take care if suppose if there is any pod which is orphaned, which has not been assigned any node, so it will also assign the orphan that orphan pod to the node, because pod is always associated with a node. So that is the function of scheduler. It keeps a check. And then comes the controller manager, cube controller manager. The controller manager oversees several smaller controller that do actions such as replicating pods and managing node replication. So replicating the nodes is being controlled by the controller manager. So this is of the four important components of a cluster master. And then comes the nodes and the node pools towards the right hand side, where you see the kubelet the kubelet container runtime, kube proxy, are the three important functions components. Kubelet is like as I said, this is controlled by API server. So kubelet is a way to interact to talk to your nodes. Kubelet is a Kubernetes agent that it's an agent, right? That process the orchestration request from the cluster master and schedule the request containers. And now comes the kube proxy. So kube proxy handles virtual networking on each node. So the proxy routes Azure traffic and manage IP addressing of service and nodes. So kube proxy is nothing. So if you see kube proxy, types of like kube proxy, types of VPN in Kubernetes while deploying Kubernetes. Um, so, or you can say uh, Azure Kubernetes baseline architecture. Yeah, this is the one of the important components. So here comes the baseline architecture of Azure component is AKS. So you can just go through it. It's a very important one. So where you actually understand how different methodologies through which this Azure Kubernetes can be deployed. So then we have uh, what you say Kubernetes subnet to IP address upgrade container image reference. So we have network contributor ACR pull. So so network topology plan the IP addresses. So different. This is the one of the baseline architecture, which you need to reference. This is while preparing for the first time Kubernetes, guys. So you can and this is the implementation of this architecture is available here. So this is the again case baseline architecture which you want to reference. So this is where you can deploy your Kubernetes plus baseline cluster. So it's a very aggressive one, I would say, very good implementation over the Kubernetes, and it's a hub spoke model which they have used so to deploy. And yeah, I think this is the one. So if you see the networking part of it, when we comes to networking, because I think after the we have to understand some Kubernetes networking also. So when you plan, so there is a base formula how you plan the IP addresses. It's a hub spoke model, and you have to plan in such a way that this is some there is a formula actually which you need to refer, integrating Azure Kubernetes to Azure. So so there are two types actually topologies, CNI. So Azure Content Networking, Azure CNI. So network topologies, network port to port traffic. So differentiation policies. Okay, network policies. This is covered in Azure CNI, Azure Cluster CNI. So so there are two types of actually the Azure CNI versus CubeNet. Yeah, this is very important, guys. Like when you these are some of the concepts in networking. networking concepts for application hosted in AKS. So Kubernetes basic is like when you deploy, right? So there are two methods to deploy, as you saw. One is the Azure CNI method, and one is the Cubenet method. So so this is different concepts, network concepts of application which you need to learn and see what are the difference between a Kubernetes and Azure CNI. So so when you see, so this is the main component which I was just trying to show you. So there are two methods of networking: Kubenet and Azure CNI. Kubenet is when you can deploy a cluster in two of the network models, Kubenet and Azure CNI networking. Kubenet is like the networks those are typically created. The structure, the VNet is created for you and configured as the cluster is deployed. So the what you say, the VNet is already created with high number of IP addresses, and you deploy Kubernetes on top of that VNet. But whereas in Azure CNI, the cluster is connected to the existing virtual network. So resources and configuration. So Kubenet is when you deploy a cluster along you when you are deploying AKS, right? You are also deploying the virtual network. So that is called CubeNet. The networks are typically created and configured as the cluster is deployed. As you deploy the cluster, the VNet will also be created, CubeNet. But on CNI, it's an advance of model of networking of Kubernetes. Like yeah, AKS clusters are connected to the existing virtual network. It's connected to the existing virtual network and configuration. This is advanced. So these are the two type of network models where the Kubernetes is being deployed. So Cubenet is like is the basic networking. Kubenet, if you say whenever you deploy Kubernetes, it is VNet is also created. So it's a very basic networking. This one is very advanced, where you have to fit in your Kubernetes into the already existing VNet. So this is like some of the things which you can go through. Azure CNI, as I said, is the advanced one. So you create a bridge with Azure Virtual Network and pods, pod-to-pod communication, pod-to-pod communication also there with a bridge. This pod, a container image is residing in this pod. This is for Azure CNI can interact with this pod with a via bridge. So one machine or one application can access another application. So isolation is there, like, but the interdependent. Applications can interact with each other through via a bridge. This is if you say this is a bridge. So you can say it's a pod to pod communication. And then there is a node to pod communication as well. So these are the two networking models through which it can be deployed. Now, now when we come to this one, right? So like here, so let me again show. This is the control panel. This is taken from Kubernetes.io. This is how their architecture reference. But the fundamentals are still the same. But that is related to the Azure. This is related to the core Kubernetes concepts. So if you see this left side, which I said you is which I told to you is Azure managed. Right side is customer managed. So if you see these are the components: etcd, scheduler, API and API server, API scheduling, and this is the controller manager. What controller manager, right? This is the cloud controller manager. This is all controlled by a control panel. And then we have in nodes we have kubelet, kproxy, and kubectl commands are all run by this thing. So these are the main components of the in control panel. We have scheduler, kube kubelet, etcd. In control panel we have nodes as well. So like it represents what are the different components of Kubernetes cluster. So we have API server, like I just explained the controller manager and etcd. These are the some of the things which one and yeah, as part of our demo also, like these are the couple of components which we will be going to deploy actually. So will you see here? So deploying a multi-container. So here we'll just see how we are deploying. So to so yeah, these are the couple of for the demo purpose. Also, we will be doing some deployment, like how we will deploying the images to the via DevOps tools, Azure DevOps. So these are the components which we'll be walking through. The Docker is a software technology that provides a system level container visualization to easily deploy application sandbox images is a redundant template. We will see the images also. We will deploy in the Azure Container Registry. Our Kubernetes cluster will take the images from the Kubernetes cluster. So, and then we will have containers which will be actually hosting the application and the OS images. And then we will have the Kubernetes, which is the actual containerized platform for hosting multiple host and mechanism deployments. And then we will have pods. A pod is the basic building block of Kubernetes and represent the executable unit of the work. So the pod is usually a single container. So a pod can contain multiple images. So and a pod is again contained in a node. So and then we have services. Services tells other pods about the services that your application provides. So this is a very important component. Then we have the deployment YAML, which will be creating deployment controller, which provides the declarative updates for pods. And then we will have Kubernetes manifest files, which will be manifest with the deployments, whereas service and pods can be defined in JSON. Uh, so service pods will be deployed in JSON, but Kubernetes manifest will have the deployment files. There's one thing which I want to show. So how we evolved in Kubernetes. This is I think can go through these to go through all these things. You can just this is the very a site for the Kubernetes which actually maintains this Kubernetes documentation and also the technical know-hows. You can learn a lot of from these site actual Kubernetes sites. So it will give you more advantage. And yes, while moving forward, let us go through. So when I go to so now it's just an overview which I've given of the Kubernetes networking. Then we have the Ingress controllers. So we'll see what are the Ingress controllers again. We'll go through cluster master and we have pods, nodes and pods. So we have kubelet, kubeproxy, which is virtual networking. Kubeproxies handle the virtual networking if it is a Azure CNI method or the kubenet method. And then we have container runtime, which actually is the component that allow containers application to run and interact with more resources, virtual network and storage. In AKS, Docker is used as container runtime. Then we have pods. Container uses pods to run an instance of an application. A pod represents a single instance of the application. Then we have pods. So this pod is contained in the container. So this is comprising of the pods actually. So these are the best just example condition Kubernetes networking when we have we have two methods, right? Two methods to deploy. And so now there comes the following service types which are available. If you see here, just so services which are available in Kubernetes like cluster IP, this service creates an internal IP for use within the cluster. However, it is suitable for internal only applications that support other workloads within the cluster. So whenever there's an internal traffic with we don't want to export to the external worlds, then you configured your Kubernetes as a cluster IP. Like internal traffic is exposed via port 80 to cluster IP, and then it is distributed to the pods with port 80. This is one cluster IP service. Then we have node port. This service creates a port mapping on the underlying node. Port mapping, it create port mapping for the underlying nodes, enabling the application to be accessed directly with the node IP and port address. So when you suppose in the front end, what we will see in the demo, front end we will deploy ASP.NET application, and the back end we will deploy Redis cache, each with a specific port. So we need to give the port number also to with the application with the, for example, Redis cache is a separate port, And for example, if we are deploying the Tomcat or Apache in the front end, then we have to give a port 80 or port 8080. So that is when we are communicating with the IP address in the port. That is where comes node port way, or it's a service. This is also called a service from like how we interact when we incoming traffic through ports and accessing through ports and the IP. Then this is the second service, node port. Third is a load balancer, so which is quite a common one, where like incoming traffic, you will here comes the ingress controller. So some application workloads implement load balancer, some represent the what you say. Apart from load balancer, there is ingress controllers. So load balancer operates on layer 4, TCP layer 4. So whenever incoming traffic comes 8 port 80, it is redirect to a particular nodes according to the request, and then it will redirect to a specific pod inside that node. So this service creates a load balancer resource, configures the external IP address, and connects the requested pods to the load balancer backend pool. So a node balancer backend pool, it will be connected. So and load balancing rules are created to the desire to allow customer traffic to reach the application. So load balancing rules are created on the desired port, right, to allow customer traffic to reach the application. So these are the backend ports for backend nodes, and these are the front end nodes. This is, you can say, front end node. This is the other backend nodes. So for one would be running, the front end nodes would be running some application. The backend ports would be running the database. So that's what is the third type of services. So now when you say after this, like just I think Ingress Controller is what we can see the next, because this is very important. Because actually, I'm spending half an hour. I think it's more than half an hour now talking, because these component is important to understand before we actually go to the. I can show you some quick demo. So these are the main components that form the heart of the Kubernetes. If you don't understand this, then it's like you won't be able to understand the actual concept behind Kubernetes. Uh, Lakshit, I would like to take a 1 minute pause here if we have any questions. Uh, Otherwise, I can continue. Let me check if we have questions. So
No questions.
yeah, I think we
No
don't have
questions. No
anything.
questions.
Yeah, that's fine. And then we are so Ingress controller. This is a very important aspect of the Kubernetes. See, either we saw in the last slide, either we could have deployed with what you say, like what you say, the load balancer, and either it could be an Ingress controller. So usually we implement via Ingress controller. So when the link which I gave you on the baseline architecture, if you see, so they have implemented. So Ingress controller works on layer 7, whereas Traffic Manager works on layer 4. So that's the difference actually. And if you see, this is load balancer implementation, and then you have the Ingress controllers as well. So this is hub and spoke model through which they have deployed. So private link and Azure key. Then we have, yeah, gateway they have deployed as part of layer 7, and this is a web application gateway. This is internal load balancer, which is layer 4. This is the application gateway, which is layer 7, which is also the ingress controller. So this is internal balancer to manage the internal nodes where our application hosted. This won't be exposed to external customer, but this application gateway would be exposed to the external customer. So this is the ingress controller or the application gateway. And this part which you are seeing, this is the load balancer, which have the internal IPs are internal IPs which are we don't want to export to the end customer, that is mapped to this internal load balancer. Whereas like the application gateway or the ingress controller is a layer 7, which is actually exposed to public. So this internal load balancer again is connected to the application gateway. You can understand in this way. So this is how it's managed. So this is the ingress controller, which is actually exposed to the public. So we'll see here. So when you create a load balancer type service, and underlying Azure load balancer resource is created, right? But the challenge is load balancers operate only at layer 4, as I said. The service is unaware of the actual applications and cannot make any other routing considerations. So then comes the ingress controllers. Ingress controllers works at layer 7. As I said, it is like a application gateway. In the OSI layer 0 to layer 7, and then it's layer at layer 4 we have the what you say the load balancer as a load balancer. In the layer 7 we have ingress controller or the application gateway. So then comes the ingress controller that works at layer 7 and can use more intelligent rules to distribute your traffic. Everyday use of Ingress controller like is to route the HTTP traffic to different applications based on the inbound URL. So see incoming traffic, so it has the logic intelligent rules to be applied. All things you can do in the Ingress controller. It requires a layer 7. So whenever an incoming traffic comes, it knows where to redirect your traffic to, block or store. And then we have a port 80 communication. So going from service to the pods, like this is a node, so it knows intelligently how and where to route the traffic. Ingress controller. There are different implementation of ingress controller concept, right? One example is the Nginx ingress controller. So we have different type of ingress controllers as well. Now we have Nginx ingress controllers. As usually you will see Nginx ingress controllers. So others type are ALB ingress controllers and GC uh, ingress controllers. So now we have this, I think, which I have explained as well: virtual network, basic networking, and advanced networking. This is Kubenet, and this is Azure CNI, which we saw, right? Basic is the Cubenet, and the advanced is Azure CNI, which I just showed you. So now we will go through the deployment units. So I think it's clear, but yeah, you can refer to these slides as well. Readily, it's available. So that's why I don't like creating slides, because all the content is available in Microsoft official document itself. So then we have exploring the deployment units. So what is the other deployments units? So we have Kubernetes use the term pods to package applications. A pod is a deployment unit and represent a running process in the cluster. It consists of one or more container and configurations. So a controller usually create pods. A controller, if you see controller in the architecture, this controller usually creates the pods. The controller is the main component. Controller usually creates pods which monitor them and provide self-healing capabilities at the cluster level, right? Pods are described by the YAML or JSON. YAML or JSON pods, like it's a YAML or JSON file. You will see that also pods that work together to provide functionality are grouped into services called microservices. So my pods that are indeed are dependent on each other. They work together to create microservices. So we have, for example, a front end pod and a back end pod could be grouped in one to one service. So a front end pod and backend pod can serve as a one service. You can deploy an application to Kubernetes by using Azure CLI, which can manage your cluster. Or there are different methods to deploy Kubernetes. One is kubelet, kubectl CLI, and the other is through deployment pipeline. We'll see how much we can cover, but yes, this is like by running kubectl command on your build agent, it is possible to deploy Kubernetes pods from Azure DevOps. So we will see that by running kubectl on a build agent, we will see that how to deploy the Kubernetes pods from Azure DevOps. It is also possible to use management API directly. So this will also we can use. Now comes the continuous or deploying network cluster. You can do either falling through the Azure shell, and this already Azure this thing available voting app which they have created to create the container, and then we can this is a very simple demo. A complex demo, it's like it's a different thing. This is the somewhat complex demo, I would say, like where we have to this is like which we have to go through is like let me go to the this thing. So now having gone through this, so say there are two demos. So this is through Azure CLI, Azure CLI, and this is through again Azure CLI as well as Azure DevOps. So I think let's try to cover the through the simple Azure CLI first, and if time permits, we will also go through the other one. But I think with this one, you will get some idea how it is like. Otherwise, you will also see. It will take 40-45 minutes from here, guys, because it's a little yeah. To understand it, we have to do like some kind of stuff. So let's see how. Let's start with the demonstration. So when we have, where is that? Yeah. So I have my subscription, right? So this is my subscription, and this is my shell prompt, right? So clear SCR. So this is my shell. I have my this thing, right? So if I go to all resources, this is already deploy my this thing is there. SQL storage is there. Storage is for CLI. This storage account is needed actually. So this is my shell Azure CLI. So I will be creating one kind of what do you say Azure group. Will create one Azure group CLI. Azure connection cluster. So we will create one cluster. We will create one, the resource group, right? And then we will create the one Kubernetes cluster with a node count as one, and enable. We will only enable also monitoring. Also, we will enable. So this is like we have created it. So it will just go to resource groups. I think this is created. So this is created now. Yeah. So yeah, this is created. So now we'll have um, so Cloud Shell already had has the CLI AKS tools already it has. So I will just it is I think it will create the this thing. It will actually create the cluster, my AKS cluster in the this thing. So we have six. Just remember, we have six resource group right now, and this is one of the resource group where we have just started to create it. While it will take some time, and till that time we have the other demo also. I can just show what is it like, and you can just go through it. It's a little lengthy one, I would say. Deploying a multi-container application as your Kubernetes service. All you need to have is your Azure subscription, one DevOps organization, and a project. So even if a project is not there, it's okay. But this is like what they have done in this one. They have what to say? They have deployed a Dockerized .NET application which is called My Health Clinic, and is deployed to Kubernetes cluster and do DevOps, and the backend is the Redis cache, right? Yeah, there is a mscale manifest file, and a load balancer is in the front end, and Redis cache is in the back end. As we saw the front end and the back end pods. So this is how they are deploying, right? So if you see here, this is like contributed by mm, Mohammed Ridwan in this one. So Kubernetes service, like when we git to git repo, here CI pipeline, it will contain to the container images. It will deploy the image to the ACR through via Docker deployment via Kubernetes. So Kubernetes will deploy the image to the ACR. The Docker it will Docker is build the image, and then it will put up a ready image to the ACR, and then the application will be launched from the container registry. So this is the build process of how it is like. So what they are doing in this demo is there are a couple of components which needs to be deployed. Like here, ACR will be deployed, AKS Azure SQL for the backend, and then we have the .NET application with the Azure DevOps Coordinator. Then they are doing configuring the database and using a CD in Azure DevOps, and then initiating the build to automatically deploy the application. This is how the second demo looks like. Yeah, so this is I can just ping a quick reference. Like I'm not sure which is the, just hold on. So I actually lost, yeah, this one. So this is the demo for the second one. So let us see till what point it has been achieved. So I think we were on the screen where it was already deploying it. So with my subscription, yeah, this has been deployed. It's still running, but yeah, I think it should be reached somewhere the point. Yeah, if you see here, six resource groups. So let me refresh it. Yeah, if you see here, now it is seven. So if you see, same thing it has been doing. Public IP has been created. So this is the, you can say, the MC part is like the managed by Azure. This is managed by Azure, and that is the one which is inside this Kubernetes actual case cluster. It's managed by you. So this is Kubernetes cluster, AKS agent pools. So these are the public IP address. This is still going on. So eight items have been created now, right now. So like public IP address, network security group, node pools. So this is, if you see, this is the Kubernetes. This is the load balancer. This is, so you we will deploy the application to this Kubernetes workload. Front-end IP address, it says this is the public IP address. Backend pools is like something which it has been registered like outbound pool is this these are the VMSS instance, the backend pools. Health probes also you can configure. So this is the load balancer layer 4. We have two backend pools here, AKS outbound backend pool and Kubernetes one. So and then we have this is the managed entity. So service principal, managed entity are the ways to connect to your Kubernetes cluster and to the different resources. And this is the virtual network to which it has been deployed. So on top of it, it's see here the virtual network is created along with the Azure Kubernetes deployment. So which type of networking it would be? It would be Azure Cubenet one. As your CNI is the, when you deploy Kubernetes and already created a VNet, but this is a Kubenet one where virtual network is created along with your cluster. So this is your virtual network with the address space. This is 8 address by default. I am not changed anything. So whatever values were there, and subnet which is taken 16. So more than, it's just more than 10,000 you will say, but generally this is not followed. 16 is not taken, and there are formulas to calculate that. So IP formula for hosting Kubernetes, for hosting Kubernetes. So this is the configure Kubernetes, and these are the like formula is there, like how much you require. Using Kubernetes networking with your own IP address is in Kubernetes service. So this is the formula, like which you have to follow. The ranges are also given. So this is a Kubernetes, right? A simple slash 24 inch can support 251 nodes cluster. It is giving you that one, right? These figures are very important to in designing your a network architecture. So in Azure CNI, it has slash 24 inch and almost 110 ports can be supported with a IP range of slash 24 in Kubernetes. This is Kubernetes through which we are deploying right now. So and this is the formula for is generally formula is needed when we are configuring Azure CNI networking. When VNet is already there, you are deploying Kubernetes on top of it. So then the formula is needed, and like this is the planning IP address of a cluster. This is where it comes into what should be the design consideration, like how much IPs you need to allocate to the pods. So these are the when you are configuring, so Cubenet, and this is the Azure CNI method of doing the planning your network architecture. And see, this is provision now. So if you see here, subnet 16 range is there. So this is not now this is the virtual machine scale set. This is the high availability concept. So it will have this node pool, one node pool, right? So this is VMSS. It's hosted in the virtual machines scale set, and this is under this particular networking. This is associated with this particular subnet, this VMSS, and yeah. So these are the some of the inbound and outbound port rules for this one. And then we have the route table. So either you can create your NSD or you can define a custom route table. So routes already defined by here. So address prefect virtual appliance. Next top is virtual appliance or virtual network gateway internet. It can it's an advanced concept, so you can just go through first, and then yeah, a case subnet is connected to a case subnet. So this is the route table, and then we have then NSD as well. So for defining custom routes, we do a route table. Then we have NSDs also, inbound security rule. These are the inbound and the outbound by default, which are open to the clusters. And public IP address is we have this public so that your customer, your application can be accessible. So this is the front end. This is the front end part. So this is how these are the couple of components which are deployed, and in this one we you have the your actual cluster, which is called my AKS cluster, and then you have this is the 1.2.7. So you can this is you can also upgrade this one. This is taken care by upgrades are taken care by the ETCD schedulers, all these things. So there are plan for upgradation also. You need to preserve extra IP addresses, otherwise you can't upgrade. So you can upgrade through portal also. This is the current one until this time. 1.22.4 is available in as your AKS. So 22. This is being deployed here. So this is the version of the cluster and namespace. If you see, you can create different namespace according to the. As of now, there are four namespaces. This is again a different concept namespace. So each dev team or anything or test team work in their own namespace. Default cube, node lease, and then public system. So these are the default namespaces. So it's a container where your developers can work in a particular allocated container. You can say namespace is a container. So different teams can have different namespaces according to their environment and their working things, right? And these are the workloads that deployments right now. You have these many deployments, and these are the number of pods which are configured by default with this one cube system. These are cube system namespace. These namespace you have not created. These are cube system namespaces. Like for OMS agent, like the monitoring matrices, like cube proxy, as I was explaining, OMS agent core DNS services, and then we have the replica sets, and then we have stateful sets, daemon sets. So daemon sets, which are backend system which keeps on running. Cube proxy, these are the system ones. Cube system namespaces. These are cube system. These are hosted in this namespaces. These workloads, which I was showing you. Then we have service and ingresses. I think this is something Kubernetes DNS is already deployed. So we'll try to deploy one more and see the difference. And then we have this persistent storage. Persistent storage. If we configure volume also, for example, any particular application. Then we have persistent storage. So this requires a detailed understanding of advanced Kubernetes concept. So this is some of the concepts, service and ingresses. This is also services with running inside Kubernetes. So this is yeah, this is it. And then there is one after this. Once we have done this, we'll create once we have done this, I will get my credentials so that I can just query. So if you see here, this is the JSON format which is they have given me. Like this is the JSON format which they have given me. The like my class for my cluster. So CLS. So yeah. Um, so now it will it will say that already is there. So yes. So dir, if you do, so if you see here, so cd cube. So this is storing my this thing, my so this is a config file. This is storing my cluster information, my sorry, my certificate SHA print, and this is just hold on. This is like cluster and the port and the MyAKS cluster and the SHA value, and this is the cache file. So yeah, so this is needed to get the control of the pods, right? And then we will have get nodes. You can configure. Kubelet is a way of interacting with your nodes, right? Which I told you earlier in the session. So kubectl will without this credential manager, right? You can't list your pods. So if you see there, it's nodes is running here. Now you can also do a pods. So pods are also there's node is also found in the one. There's no pod which is running. We will deploy the now container images. We will deploy in the pod. So this in the node is running. This is which you saw earlier also. This is just 10 minutes before which we have created this pod. And now we will create a file name as your vote.yaml. So we'll just go through that link again. Yeah, so create an AKS cluster. So this is like get nodes. Now create a file name as your vote.yaml and copy into YAML definition. So I think I have already have this, but yes, as your yeah, this is the latest one. So this week I think we can deploy. So if you see here YAML file, try to understand this one. This is the deployment YAML file. So this is the Azure vote bank. This is the front end speculations. These are the specifications. Replica is one set, which you said, which you just saw selector one replica set for the node. If any higher availability is required, it will replicate by one. Increment value of the node by one. This is replicas. Azure vote back is the backend, and application deployers. This is the name. Specification again. Container is this is the vote back. Redis image which you have deploying, and CPU also we have allocating CPU and the memory, and this is the CPU and memory which we are allocating to the Redis cache. Container port is like node port which I was showing you. This is 67 then for Redis cache, and for Azure backend, it's also again the same. This is again the replica front end. This now comes the front end. This is the kind deployment front end replica one. So here we have deployed again the request CPU and like limits maximum CPU allocation. This is minimum. This is maximum values. Port is 80 for the front end. For the back end is 67, which is a Redis cache, and this is again name Redis backend pool and the service. Now this is service. Now previously it was a kind is deployment here. This is deployment. All you see is a manifest is that now we have deployment kind also. We have service also. We have deployment also. Deployment service is there, and we have a service also. So we have two deployments and two services. Deployments is Azure where vote back and Azure vote front, and this is like deployment type of the kind. This is service Azure vote back, where you actually define the what you say the service your front back. So front is the load balancer and the back end is the Redis cache. Is the same thing. Now we will do a cube apply, cube cuttle apply. So I think. So this is the command to like this is like already I have this YAML file. So let me apply it. So this is like once deployed. So now I'm trying to deploy the service. Actually, it says Azure front end only created. So it says I think something is wrong here. So you will destroy. So it says like Wood front end only created. Let me open. So I think it should be deployed in this way, but let's see what's the error. So again deploy. So when we will do get pods, it will list actually no source form. Okay. So actually it is deployed, but the backend service is somehow not getting deployed. So if you do a get service as your front end vote front because it has been created, watch to see they see cluster IP also been assigned now. So only thing is the application is not getting launched in this. So front end, if you see, let me go to the namespaces ingress. As your front, see, this has been deployed. So now this application is not running because our YAML was wrong. It's not taking, this application is not launching because only this is successful. It has given only one output, which is service is only created, deployment has not been created. So I think that's why it is not browsing. But let's figure out if we can fix it. We'll try to fix it. So open file. So Azure vote.yaml. So let's open this. So it says only. So this service is only been created. This one. So deployment has not been created. There are a couple of errors in this one. So like each container in a pod must have a unique name. Cannot be updated. So it seems only one service is getting deployed, but although I'm not able to find any syntax error, let me check for syntax error also. Variety heaven. Let's delete the previous one maybe. So so I think there is some maps keys must be unique YAML. So I think anyhow I'm able to access maybe. Lakshit, let me give you the IP. Let me try to give. I think I will be behind the VPN, so I'm not sure if I will be able to access it. So check if you are able to access. Although I'm not sure this should work, but let's try to. I think. Port is 31978.78. Yeah, this is port blocked. By any chance, you are able to access this, this one? Um, what is the thing which is coming for you? Nakshit, can you just try to access it? No issues. Ports and then okay, I think we'll just import it and see. I think it's not working, so I think we have to end this demo now right here. But I think conceptually it's must be cleared somehow that how it works. So I think that's it. But yes, I think I would encourage you to perform this demo. If you have any doubts, especially in the big demo, which is which is I think the Azure DevOps Labs one. This is the most important one. So just go through it. If you have any issues, let me know. Think that. Thanks, Lakshit. I think over to you. Yeah.
Thank you, sir. Thank you for the session on Azure Kubernetes. That was a basically very insightful session. The theory part you have covered, I personally liked it. Like the Microsoft Docs. See, everything is available online. We all know, but the way you have explained everything so clearly, that was fascinating to us. So,
Thank you.
thanks for joining in. And the demo you have shown, I'll try to work it on. And because my Azure subscription is in not working properly, I'm not sure why it is happening. So, I'll try to
Okay.
make it. I
The
just tag you
demo
from
for
the
the
demo
Azure
session.
from Azure DevOps I could have shown, but today my agent pools are not working fine. So, so we'll try
Yes,
to
so this debugging.
see. Yeah.
Yes, so
So
this
we'll
happens
see.
with us every time. So no worries, we can't say if some code is
Uh,
running right now, so it will run after 10 minutes also. This happens every time. So
yeah.
no worries. Yes. So thank you, sir. Thank you for joining in. I hope we will be having a lot more insightful session in the future.
Yeah. For sure. Yeah.
And we have a lot more things planned for you. Do join our Discord community channel. We do every Friday. We do a quiz there, and top five winners get the goodies there. So thank you guys. Thank you all for joining, and thank you, sir. Have a nice day.
Thank you. Thanks, Lakshit. Thank you. Bye.